think we all know what chat architecture is. The only reason why I added this is because you get people saying like, I want ChatGPT, but I want it in my app. So you have to, if you're a developer, say, well, I have to know how to implement a chatbot. So this is describing how to do a chatbot, but I think at this point, we know how to do that. Okay, let's talk about the Java APIs. So to access some of these language models, there's a couple different ways. There's usually Python native, I think, for most of these things. But we're going to focus on the REST interfaces and then the wrappers around that, the Java wrapper. But once you have the REST, obviously you have different language bindings for that. Oh, the third thing down here at the bottom, gateways. There are some companies that provide a gateway. In other words, you use I think OpenRouter does, openrouter.ai. If you use the OpenAI API, so to access ChatGPT, they have their own API. So if you use that API and you contact, instead of OpenAI, you contact OpenRouter. So OpenRouter will then route you to different language models on the back end. So it's you use one API, the OpenAI API, and then you specify which language model you want, and then it will route you. So it's called a gateway. But I think we're going to skip that. But that is another way of accessing language models. We're going to talk about LangChain for J, which does something in an abstract sense similar, but it does it from the programming API. In other words, I'm going to give you the LangChain API, and under the hood, then I will call OpenAI or Anthropic or Gemini, Google, or DeepSeek or whatever. So it's a different approach, right? And most of these APIs are mostly stateless. There's some companies are adding stateful APIs. I think OpenAI has added stateful APIs, but for the most part, they're stateless. Here's the LangChain for J, GitHub. Very easy to use. Here's an example. With my prompt here, how should I learn Java? I mean, it's a zero-shot prompt, right? And what is this one? Okay, this one is giving it instructions. So like the instruction is respond like you're a funny comedian, which could be dangerous actually if you're demoing this in front of a big crowd. How should I learn Java? So this is more of an instruction. This is what's called a system message. So basically how you want the language model to behave. Okay. All right, so there's a couple of ways to get a language model to return useful. And here are the differences. Obviously, there's simple prompt, right? And the simple prompt is that you have the request and you have your context window. So you put the stuff into the context, right? Like here, this is the base simple prompt. Here we're adding context. So we can copy paste something into the prompt, or we're writing a Java program. So like add this file or these files into the prompt, then send it to the language model. So they're sort of like prompt and context. The downside of this is that there could be stuff in the file or in the collection of files that aren't related, right? It's just useless information. So, but this is one way of doing it. Then there's RAG, what I talked about, and RAG is very similar to this one, right? This is very similar to the prompt plus context. The only thing I'm doing here is that I'm using an external data source or even the web, putting things programmatically into the context. So it's very similar to the prior slide, except they're doing it a little bit more fine-grained. Now, there's another way. So if you're a data scientist, and not too many of us are data scientists, you can actually change the weights of the language model. Remember, I talked about those little boxes. It could be billions of those boxes. Well, if you want to change those boxes, you can change how something moves through the neural network. But you really have to be a data scientist. You really have to know about data science to do that. It's not just for the average application developer. So it's for a smaller audience, right? There's this many application developers. There's maybe this many data scientists. So it's not something to be taken lightly. But if you know what you're doing, you could fine tune a language model. Say like, I want to create a model that knows a lot about medical certain diseases, right? Or radiology. Well, that's not an average language model. So I want to tweak an existing one. So that there's something called transfer learning in AI speak is called transfer learning. I'm taking an existing language model, existing what's called a foundation model, and I want to tweak it so it knows about radiology, or it knows about trading, or it knows about certain diseases. So there you're fine tuning a model. So that's another possibility. So we talked about prompt plus context, RAG systems. Fine tune is that it's also possible, but you have to be a data scientist. And then you could use a fine-tuned model with a RAG system. So these are basic ways to use a model. So prompt techniques are obviously just strings, right? So it doesn't require super IT expertise. It's just strings, right? So those are the easiest. So they're not exactly complicated. So that's the easiest one. RAG system is probably next, but that involves, having a database and maintaining a database and things like that. But you're still dealing with strings. And RAG systems, since they have more context, it eliminates, pardon me, not eliminates, it reduces the chance for hallucinations. It doesn't eliminate hallucinations because language models are probabilistic. You can reduce it as much as you can, but it doesn't eliminate it. It just reduces it. And the better RAG systems reduce it to with a small number, but it's still a possibility. It's still a possibility. Again, these are probabilistic entities. We're not in determinism. We're not deterministic IT anymore. We're probabilistic IT. And the nature of language models, until further notice, the nature of language models are probabilistic. Even DeepSeek, right? That uses conventional underneath the hood. It's a language model. Right? It turns out it's so-called mixture of experts language model. That still hallucinates, right? As I said, it uses the new reasoning models use chain of thought. Chain of thought is still doesn't always give you, doesn't guarantee the correct answer. As a matter of fact, I was reading the original paper on chain of thought, and the researchers say in that paper, it doesn't guarantee it gives you the right answer. Okay, so but those in green, so I put it in green that the ones that the two top ones, those do not modify the neural network weights. Anytime you're modifying the weights of the neural network, you better be a data scientist. And you better have a good legal department. Because now the results, if your company is somehow audited or something happens where there's a legal problem, like for example, you develop a system for offering mortgages to people, and somebody gets turned down because of your neural network, and you're going to ask, well, tell me what happened here. Why did it turn down this couple, and then you turn down them for a mortgage? You better have the right answer. And if you're a data scientist, you would keep an audit trail, and you would log. And here's a chain of thought how to. So you better do that, or else it's pretty bad for your company, right? So there's fine tuning, right? And then train your own model. That's even a smaller subset of people. I mean, so you have prompt techniques. I mean, practically the world can use a chatbot, right? And then retrieval augmented systems. Okay, we're getting smaller, fine tuning. You have to be a data scientist. Train your own model. You have to be a data scientist, and you have to have a lot of money. It's very expensive. And then maybe 5 people on the planet can write their own language model. So those are the different techniques. And you say, well, which one should I use? Well, okay, start simple. Try simple techniques, prompt techniques, zero shot, try a few shot, then try RAG. And then also with RAG, don't forget, you're sending a lot of data back and forth, especially with a chatbot. The chatbot has to keep track of the entire conversation. So a chatbot is the data that's being sent back and forth gets bigger and bigger and bigger and bigger as the conversation goes along, because it has to maintain the context of the conversation. So if the data costs start to get expensive, maybe RAG is not the right answer. Then you have to go to fine tuning. Okay. I'm gonna skip that. Okay. There are other strategies for improving responses, certainly well beyond what this presentation has covered, but just for your own information, there are some advanced RAG techniques. You might want to use a reasoning language model if the problem domain is more complicated than just looking up something. Right? If it's just looking up something in your docs, you might not want to use a reasoning model for that. It seems overkill, right? But you might want to switch to a different language model. So I think in practice, people have found the jump in performance, the jump in not just performance, but effectiveness of a language model. It's not so much switching language models. So you might get, an epsilon difference between language models. It's a little better, but was it worth we doing all that? So different language models, the top language models behave very similarly. In practice, what I've read is that for RAG systems, your chunk, what's called your chunking algorithm, by changing that affects your result more than changing language models. So when I mean chunking out strategy, I mean, so when you put things into a RAG system, how you store it in a database? Well, do I store words? Do I store sentences? Do I store paragraphs? Do I store HTML divs? Do I store chapters? So you have to decide what is the size of my chunk. And it turns out that clever use of clever chunking strategies affect your output more than just switching a language model. Also, in this middle thing here, multi-language model. So I think now we're into a period of time where people aren't just using one language model in your program. You might want to use several language models. You might want to use a panel of language models, like use one, get the output from one, then ask the other three, what do you think of this? Why don't you ask, like, you ask the Google, you ask Gemini, it's like, I got this output from OpenAI, and there's Google, there's Anthropic, there's DeepSeek, you have your access to those three. Then you ask, well, what do you think of what OpenAI's result was? I want you to grade it. So I mean that's NASA does that when they send things in space, right? There's a panel of machines that vote on what to do when something happens, right? And they take a vote. That's something similar. So you can use a collection of language models. I wrote something on LinkedIn. This was interesting. So I asked OpenAI to generate. It was kind of funny. I asked it to explain quantum computing to a heavy metal band, and it gave me back, a couple of paragraphs explaining it to a heavy metal band. And then I said, I want you to rate your result based on this criteria, right? And I gave it like 4 criteria, and how concise it was, how clear it was, blah, blah, blah. So I gave it criteria and the description of criteria, and I want you to rate yourself. In other words, give me a report card of yourself. So I said, well, I'll give myself a 6 out of 10 here. I gave myself a 3 out of 5 here. This one I did pretty good. I did 8 out of 10. So I said, and now go back and rewrite your original response, but I want 10 out of 10. And it gave me back exactly what I wanted. So you're now using not just one language model, you're using collections of language models. And I wouldn't doubt in the future that we have swarms of language models, it can take 5 years from now. Because now language models are getting smaller and smaller. We're running them in devices, what even smaller than phones. So collections of language models would be an interesting architecture. Okay. So what does this all mean for us, right, developers? As I was saying earlier before we just got started, I worry about the young developers, right? I mean, if you're a good instructor, you know how to incorporate this in a young developer. You tell people like, well, your job's not at risk, but if you understand how this works and how you can incorporate that. And it's not just about chatbots and not just about generating code. It's about patterns and how we can apply patterns to the entire software development process. And if you explain it that way and you explain it like, this is like when IDEs came out, right? What happened to text editors? Well, then they went away. He goes, oh, what are we gonna do now? We have a better tool. So think of it as a better tool. So, and also there's maybe you don't use generative AI. So this little simple flow chart here. So if you have something, you come through a task, and of course, are there subtasks? The first thing you ask, if you get wrong results, is your company at risk? Or is your job at risk if you're wrong? If it's yes, I guess what? I am not using generative AI. I'm using traditional IT because traditional IT is good for a lot of things, right? If it doesn't involve something that's creative or pattern, if it doesn't have patterns, don't use AI, right? But if there are patterns, then you say, well, okay, here down here, let's find out if there are ethics issues, or we have to involve our legal department, right? So you might go through this flowchart and it's like, you know what? We don't use generative AI. We don't even use AI at all. There are no patterns. If there are no patterns, we do a SQL query. This problem involves a SQL query and we're done. Okay. So here are some trends, and I'll end with this. But the reasoning models are starting to grow. I mean, I think DeepSeek has really actually the one before. There's a company in France, Mistral. So Mistral was one of the first language model companies to use the chain of thought inside their language model. But I guess they were not very good at marketing it. But DeepSeek has almost like stolen their thunder. And oddly enough, this stuff is patented by Google. So reasoning models are starting to become very, very popular for harder problems that involve a chain of thinking, a chain of thought, right? And the so-called mixture of experts, that's another thing that DeepSeek used. So we know that we had this neural network, and neural networks can be massive in size, right? It's like 200 billion of these little probability boxes. Well, this whole so-called mixture of experts says like, you know what? We have this big data structure and it's sparse. We're only using a tiny part of it. So it's like, back in the old days, if you had a huge matrix and it's a sparse matrix, you might think like, well, maybe I should come up with some more optimal data structure because we don't need, if you have a million by a million matrix and you're only using a few boxes over here, do you need to store this whole thing in memory? So what mixture of experts does, it basically takes a language model like that. It says like, I'm going to have a collection of neural networks. I'm going to use a collection of neural networks, not one massive one, but a collection of them. And I'm going to route the query in the prompt to that particular neural network, or part of this prompt to that neural network. So a mixture of experts is like a collection of neural networks. So that's another trend. And then there's also a distilled model where you have a big neural network, and you're using chain of thought, and you ask it like, well, tell me the thought process. In other words, solve this problem and give me the chains. Give me how are you solving the problem? How you solve all the sub problems. And it gives you like, well, I solved this first, and then I did this, and I had to query this, and let me go back to this. So it gives sort of like, not the algorithm, but the step-by-step way of how it went about solving it. So if you have that, then why don't you take that, feed that to a smaller model, a way smaller model that's more efficient. So you use the big model to find out how it thought, and take that and then program a smaller model. So there you're using a smaller model. It's way more efficient. It uses, less memory, and it's faster. So that's called a distilled model. And DeepSeek is a distilled model. And I think talk about this distillation. We're at the last slide. So any questions on stuff we covered?